to larger and larger scales, like the sea, for instance, you have different dynamics. You have a long coherent dynamic, let's say, for the whole of ocean, and then you have short coherent dynamics like waves and these kind of things. It is connected actually even with the Earth and Moon rotation, right? So the dynamics are very complex. We typically want to pinpoint one particular dynamics for something, which is completely understandable because we cannot get the world as it is. So we have to split it in small parts. But if we want to understand it, then somehow we need to put together all the small parts and understand that the dynamics probably is much more complex than just individual things, right? If we go to atmospherics, for instance, of course, a hurricane is much more than a connection of clouds or just wind. Actually, to me, it's very, very interesting because it is very similar to galaxies. When you get the eye of the hurricane, the dynamics in the eye of the hurricane is completely different to the rest of the hurricane. And it's still part of it, right? So you think in a hurricane and it is, very, with a high winds, a very heavy rain, but still you have a part of it where everything is calm. So different dynamics playing in the same global dynamics, let's say. Okay, so because in astrophysics, of course, as a physicist, then I will focus mainly on the universe, but we could focus on biology, geology, everything, right? So actually, some months ago, we had filming at the observatory. This is Canary Islands, actually, and this is our Milky Way, the narrow sky background. And they asked me for this film, what do you think or what do you dream when you look at the sky or at the night? And then it was a kind of, for a scientist, this kind of question was a kind of, okay, we are in an observatory, you would typically think about spectrum measurements, but what do I feel when I look at the sky? Well, I think it's helped me to contextualize my life, actually, because typically you are focusing in different things, but when you are looking at something like this, so huge, and we typically think the universe and myself are two different things. But this is not true. This is the way we are kind of seeing this, but we are part of it as much as our iron in the blood come from the stars. All our atoms are formed in cosmic events, right? So there is no such a difference like the cosmic and myself. So what we are looking at the sky, what are we looking at individually or from? So we could spend months talking about different events, right? Here we have a very beautiful image of a star-forming region. You can see actually that there are different parts. So you have some gas, some stars which are being born. So it's a kind of, let's say, a bit of chaos, but in the chaos you are getting things that are very well organized, like stars and this kind of thing. So from chaos, the dynamics change, makes different things in the universe to function, right? To function in a coherent way. So we have changes of dynamics. We go from some chaos, then some organization, then maybe come back to the chaos. So dynamics is always, as its words say, we typically tend to think in dynamics like something has a given dynamic, has a given dynamic right now or for a period of time, but it can change, right? And we see this all the time. So yeah, so when we see the stars at night, we are actually seeing much more than beauty. It is so beautiful, but on top of that, stars are responsible to actually create all the small blocking of what matter and different things are made of, atoms of different types. So here is a list of the many different elements that stars can create until iron. Actually, iron will be the last component that a star is able to produce, because in order to go farther to heavier elements, you need energy. and the star don't have energy. In order to produce that, actually, in order to release the iron from the center of the star where it is created, you need an explosion. So actually, you know, iron for us is pretty important. If you don't have enough iron in your blood, you will be like tired and so on. So the doctor will, so actually what is missing is a bit of supernova in your blood, because without supernovae or novae, like when you have explosions, this is where the iron gets released to the medium. Actually, it is so important, this explosion, these changes in the dynamics. This is how the stars are forming different elements, but only when they explode, they release these elements to the medium. So we say it is enriching the medium. From that medium, together with other chemical elements, they will form new stars, and they will go beyond. So life is never just in the cycle of stars. It is many life that they really need in order to create the different elements we use and we know. Okay, so an actual, well, this is another supernova remnant. So basically this is what you see after 1,000 years after the explosion of the star. This is actually, it tells you that there is a certain dynamic. When you see these kind of pictures, different colors represent different elements. So it's not random. There are some structures, some of them are just amazing, right? So it let us know that the different dynamics that we have at the universe, right? Just put this a nice picture there because I enjoyed them a lot. Okay, let's go to galaxies. As in the case of the hurricanes, galaxy is much more than a collection of star, gas, and dust, okay? So, and still, even though you have many components, it has a global dynamics. But while there is a global dynamics, still you have individual stars. And the individual stars are doing their thing. But they are not, I mean, while each individual part are doing their work, they have their own dynamics, they are playing the whole dynamic as well. So we are always playing with this dynamics across scales. Of course, you have galaxies and they can interact with other galaxies. In addition to the galaxy itself, some of the galaxies, well, we think most of them have a black hole in the center. Some of them, we call it active, and some of them might be active in the past, but not right now. And some of them actually eject this kind of jets, but they are very powerful. This is one of the most powerful events in the universe. Actually, this is what we are basically seeing dominating the gamma ray sky, which is the strongest electromagnetic emission that we can observe. These are my love magic telescope. These are weird telescope, kind of optical telescope, very fast, that allow us to explore the most extreme universe. And this is how we get to study the jets I was describing before. So basically these galaxies that have these jets, as you can see, they are born very close to the black hole and they are ejected. Here we have a massive amount of energy and also particles. You can see here in blue, represented in blue, what we call the gamma rays that don't have any, these are photons to have charge, so they go straight, in a straight line, and there were others that were deviating because of their charged particles, and they interact with the magnetic field. So this is what happened when these gamma rays reach to the top of the atmosphere. It is too energetic, it cannot enter in the atmosphere, but it produces a shower of particles. And this particle is faster than the speed of light in the atmosphere. So what you get is flashes of light, very short, in nanoseconds, so really, really short, in our atmosphere. So this light is called Cherenkov, and this is what we study. So we study our own atmosphere in order to understand the most extreme universe. So when we think, again, about the universe and myself, well, keep in mind that the most extreme events observed in gamma rays, in order to understand them, what we need to understand is our own atmosphere. So there is no such a thing as separation. Actually, while we are here, just in our hand, we are getting like 600 cosmic rays, such of these particles created in this extreme environment. They are just going through us right now. So there is no such a separation, right? We already know. Well, this is a collection of Cherenkov telescope we are building and how we will observe, but let's not go into the details. Of course, when you focus in one galaxy, it is already a whole universe. I mean, you have so many dynamics. In order to understand just one single galaxy, you can spend your life, and you will still not understand, right? But of course, you zoom out, and you get many more galaxies, right? And if you zoom out, you get many, many more. This is actually the deepest image done by James Webb satellite. And you can see billions of galaxies in just one image. But still, let's zoom out a bit more, and we'll get to this. This might remind us to neural connections, actually. But this is the distribution of galaxy and galaxy cluster in the universe. Around 2000, there were some simulations where we, using real data, and together with simulations, the publication or the results was that the galaxy seems to not be just random distributed. If you zoom out enough and you check for the distribution, they are connected through filaments. That was just a simulation, but nowadays we have actually data. And it demonstrates that they're not randomly distributed. They are in a kind of, this kind of connections. Of course, you see the whole network, the cosmic web. But if you zoom in, again, you see, of course, little things, more galaxies, galaxy clusters, etc. So we are always in this kind of multidynamics, right? So regarding this universe and myself, like different things, I would like to briefly mention also gravitational waves. Probably you have heard about them because they have been so popular in the last years. So relativity, Einstein changed our view of gravity, right? So what Einstein came to say, it was that, okay, a mass can distort actually the space we are in. And of course, if the mass moves, then the space should move. That will give you gravitational waves. Until 2015, it was just a prediction of the general relativity. However, in 2015, for the first time, we detected actually there are two black holes here that you can not see because they're black. But you can see that when they are rotating, they are changing the medium, right? Until they get to merge, and then everything is stabilized. This is a movie just to understand the phenomena. But 2015, that was the first time that we detected this kind of waving, okay, in the space itself. So it is amazing how two black holes dancing millions of years from here actually can affect the Earth in a way that we can measure it. This, for me, this is amazing. So that demonstrates the connection, right? We don't have to imagine to invent some connection. This is there and we can measure it. And actually, this is another event, the gravitational wave. In this case, this is the only case we saw two neutron stars that actually merging. And this was in 2017. This was an amazing event. You could see that after the merge, you get this kind of very extreme jet. And this is a kilonova. Kilonova is much stronger than a supernova. Supernova is the death of a star. And actually, this result was key for science. Until then, we didn't know how at least half of the heavy elements, how were they formed. As I said, stars can reach iron, but below iron, okay, beyond iron, we had some theories, but still we were not sure how exactly they were created. That event of two neutron stars actually create a kilonova. That was the first time that we can observe directly. In two ways, we detected the waving of the actual space, so the gravitational wave, and we, in the electromagnetic spectrum, so we could detect in X-rays, radio, optical, the emission. So it's like having two senses, right? You can see and you can hear. This is the only event that we could do. We are, of course, searching for more, but it's not that easy. And it was so important because we could see in real time from one day to the next how, in the spectroscopy taken from the telescopes, how the heavy elements were formed. It was so impressive, so amazing to see how gold was formed. Like the gold we have in a ring is coming from this kind of events. Otherwise, if you don't have this kind of very energetic events, you cannot create this kind of elements. So it's amazing to see in real time what is going on. So how do we detect gravitational waves? This is, for me, this is amazing. As I said, the space is supposed to shake, right? But how do we measure this? So what is the effect on the Earth when a gravitational wave comes? Basically, it shakes the Earth. So the size of the Earth change. So if it is coming from here, it will skew here and enlarge on the other side, etc. So this is how we measure. Of course, it is not only the Earth. Also, I get a squish, right? Everything goes a squish, but because of the scales, you cannot measure. You can measure in something really big like the Earth, right? So this is how we measure. Actually, one of the detectors, the first one that discovered the gravitational wave in the US, the LIGO, basically it is very simple, but difficult technically. You have two tunnels, which are perpendicular, and we are all the time measuring the distance, or the size, the length of these two tunnels. If the Earth is stable and always there is no movement, they will always measure the same thing, right? 4 kilometers and 4 kilometers. But if it is not the case and there is any shifting, then you will start seeing changes. So what we do is to use light going back and forth, and if the length change, the pattern interference will change. And this is how they discover actually. But look, which precision do we need to measure such a thing? 10 to minus 19. So this is smaller than the size of a proton, and actually is how it's like the size of a hair, not at the moon, but twice the distance of the moon. It's a really incredible precision to get there. Okay, so we have been talking about universal choreography, so all the different scales, and now I would like to make some mimics or some, I will throw some ideas. It is far from being probably not yet scientific. It is just some ideas that we could explore. But so life, in terms of the universe dynamics, can we understand also life as a sum of different rhythmic oscillators and different choreographies that are not apart from everything, right? So it is a continuum, a spectrum from the very little, the large, we will be somewhere in the middle, right? Okay, so of course, there has been already many works on EEG. Already, well, we have this delta, theta, alpha wavelengths, etc. But I was wondering if it might be also, because it reached only 100 hertz. So we have heard already in different talks that, well, this is okay up to low frequencies, but maybe there is much more rhythm that we are not taking into account. And only now, because of the work of Anirban, Pendra, and all these teams, we can reach to higher frequencies with the DDG that they have been developing. So basically, we can get to megahertz or even higher gigahertz. So I think it is really interesting. It is still, we are just starting in the field, so, but I think it can get very, very interesting. And I got even more interesting with Anirban, like 1 year ago. He showed me some measurements in the megahertz, so from 6 megahertz to 26 megahertz of a given part of a brain of a person, and actually you can see that there are some jumps. Apparently this is not the standard behavior that was typically observed, and it caught my attention from where these different changes or steps um, will come, because sometimes there are major. To me, it makes me think to coherent. Maybe it is not, but what came to my mind was coherent, because if you have different parts, you might get something that is not changing the steps. But there are other options with, if you take into account quantum physics. So I will just throw there some ideas. So we know that the brain is very complex with different parts here and there and so on. But in order to explain these jumps, I was thinking in couple oscillators. You can have different oscillators. And if the system, at the beginning, the frequency is different. But if you let the whole system to allow to move, it is free, then at some point it gets coupled. If the system is free, of course. If it has very fixed limits, it might not work. So I was thinking in phase locking and how the coherent or the phase locking could change the perception. So here we have some examples. These are just simulations, not real data. So the colored ones are basically the oscillation that we'll expect from different parts. The white one will be the interference or the final pattern when you have all together. So if you have a chaotic state, so basically each of the different parts are not connected, are not working together, you will get something like that. So there is not a pattern, okay? If you have a partial synchronization or coherent state where not all of them are in sync, but you start having something cleaner, right? Even though there is some dynamical changing from part to part. And if you have perfect coherence among the different parts, of course, you will get a very clean, coherent spectrum, right? Let's think also, Professor Becerra actually was about to show us this in the first day, but there was no time. So when you think these are birds, and it is what they can do in a coherent way is much more than just the sum of the multiplication of different birds, right? It is amazing how a system that enters in coherence can express or can have emergent properties that's not equal to the sum of different parts. The different there are new emergent dynamics or properties that appear when a system is working in coherence. It's much more than just summing up effect. At the end of the spectrum, so if, let's say, the extreme case of extreme correlation, let's say we can get even condensate that actually, so many people have been talking about this. Probably, yeah, actually, Anirban and Froelich and have been introducing it as a possibility. So I will not go too deep on this, but this is a possibility just in the case. Now let's go to some examples of measurement with the DDG. So in addition to these bumps, also they have here the full DDG. So you have actually 12 bands in different frequencies, as you can see. Up to 100 hertz, it will be the normal EEG that we are used to, and then it goes up in frequency, okay? And there are 14 sensors around the Earth, the Earth, I'm too much into planets. The head, okay? Okay, this is a pretty complicated image, and I think, DDG is really an impressive instrument, but of course, calibrations and a lot of work is needed. I will just bring your the attention about a different thing. Well, you can see that here, for instance, there is an activity. There are some points that are kind of constant, and then suddenly there is a bunch. There is some others where the activity changes differently. So let's focus in these two bands only. So you have this one where I will call like these 3 points, like this one, this one, have a kind of local coherence. And suddenly something happened that there is a more global coherence. So there are the two. While in this one, which is 500 to 600 megahertz, as you can see, actually the emission is more like global, except this area and this area. You can see that there is a different pattern, right? Everything is more like globally changing. Well, this is work to be done. These are just some ideas I would like to bring, but instead of finding one single dynamic that can be causing consciousness, maybe we need to play with different rhythms that are working in a coherent way. Maybe some local plus some more global. We don't know, but this is a starting point. Actually, I would like to thank Pushpendra and Irvan, all the team, because they have been helping a lot doing the measurement. So that's my idea. So, and actually, the system will change a lot. If we imagine a system that will have only local mode, so short length coherence, so more locally dynamics, it will change very much when you move to a more global, less fragmented dynamics in our brain. Like in the galaxies, right? You still have different stars doing what they have to do, but they are also playing the whole dynamic of the galaxy, something like that. Of course, when you have a more global behavior, probably the information flow is optimized as well. Okay, so this is the plot we have before, and now I want to introduce something else, and it's the perception resolution. So these red bands will represent our perception resolution. Of course, even though we might have this rhythm in megahertz or gigahertz, we are not functioning in our daily life in megahertz, right? Because otherwise we will be crazy, right? What we get is a kind of integration mean in a given perception time, right? And but still, it is important how this perception in that band behave, even if it is at shorter scale than your own perception. Why? Because if you get the mean here, the mean here, mean here, it will be changing. So you will be, your system, your feelings, your emotions, everything will be like still moving. While if you have a more consistent dynamics, it can get also to some different perception, probably. So some example, like a structural silence, I will call it. So it's a kind of silence that is not, because we are typically considering silence like the absence of sound, right? There is sound, there is silence. But it's not completely true. Actually, in the music, if you are hearing music, at the beginning it's like, okay, there is music, there is only music, there is only sound. But if you switch off, okay, there is sound, silence, sound, silent. But if you really pay a lot of attention within the music, there is silence, because silence is the base of sound. And it's not silence, sound, because in that way we would never could produce sound or a melody. So the silence is very important for the melody itself. It's as integral part of the melody. So sometimes we are thinking dualities. Well, it is not just our perception. Probably is not fine enough to realize. And specifically, if you have a system that is not well aligned, let's say, of working more coherent or in a more global way, you have a lot of noise. And that noise might disturb you to feel what is in there, actually. So you can really perceive only the top, but not the bottom. Here, your perception might be the largest, so the peaks will be the strongest, the most intensity, and also the valleys will be the most profound. So you will be between the sound and the silent at the same time, because it is within the perception resolution. So within your perception resolution, part of the time you will be perceiving, part of the time you might be at rest at the same time. So that will explain these kind of things, like a silence that is not the opposite to sound, but a silence that is the sound, actually, that makes possible the sound. Similar here, I was mentioning the hurricane. You have very strong winds, you have crazy rain, but still you have a part where nothing is happening. It's completely at rest in the same dynamics. Okay, so something else. So like an expansion of perception. Of course, if your system is aligned, then, as I say, the valleys get deeper, the peaks get higher, so and you have less noise. That means you are more sensitive, okay? So if it is working as sequential global coherence, if you have different parts that are working not simultaneously, but working, you will have this kind of feel, right? Perception feel. However, in a global coherence, the field might expand. Not only expand, look, the red point is at the same coordinates in this plot, just that the field expand, okay? But this is even more. In a global coherence, now the red point might not be located in the same position. I mean, the red point will be in the same position, but from where you are looking at, or from where you are, let's say, referencing it, it's different things. So the red point is the same thing, it's the same position, but you might feel it different. So the perception might change, even though, so from a local to a coherent or more global system. What about time? There is this timelessness experience. And I think when you have a fragmented system, because what is time, actually? Typically, I think time is measured when you see differences, right? So if you have a fragmented system, you have, now this is activated, now this one, so you can check what are the changes. But if you are working in a more global framework, then there might not be that changes, or at least not in your perception range. So it might look like no time. Of course, there is a time, but the feeling of time might change. So it might change from different times to really a functional eternity. You are just at present. Here as an example with clocks. So if you have a clock that the environment is dirty, they are not rotating when they have to rotate, there are some, the system is just moving like in a forced way. It's not, then what you will get, I mean, if you are touching your clock, it's like you will be in the past or in the future, but you will never be properly on time, right? However, if the system is working in a coherent way, you don't have to touch it. Actually, if you touch it, you will create a problem with time. When a system is working, just leave it there. When the time is actually proper, you don't have to touch it. And if you touch it, then you create the problem there, right? And I think it can be connected with the dissolution of the center. When you move from a fragmented system to a more global one, you is probably, or the brain as a function, doesn't need to have this kind of a center anymore. Like when you have fragmented, and we are a very complex system. It is very difficult to understand. I'm just throwing some ideas, but when you have different inputs from inside, from outside, how everything is working, you put all this together. If it is not working properly aligned, a center or a manager is needed to adjust some things, okay? But whenever everything just align and it's working in a coherent way, you might not need this kind of manager because the system is already working smoothly. So it could get this feeling of dissolution of the center, or the I that we typically call. Also, we could, even in extreme cases, maybe we can get to functional superposition, I will call it. Typically, we think in asleep or awake. Okay, these are like different states, so you cannot. But if you have like different dynamics well aligned, where you have some local dynamics together with a global dynamics, you can get that superposition. So basically, when the body sleeps, you can be aware, and the other way around, you can be aware while your body is resting. Still in an active way, but resting means the dynamics is stable. Okay, another thing is the transparency of the perception. So when there is a coherence stabilized, of course, you have a reduction of the noise. But it's not only that. if your system is very fragmented, then it's like seeing a movie by a snapshot, because now you will get a snapshot from my knee. Now I get a snapshot from, so you get a snapshot. And the brain probably needs to do a lot of simulation with such a snapshot. You have to extrapolate. What happened in a more global dynamics? You could be feeling the different things at the same time. So it's like seeing the full movie. It's not just a snapshot here and there, but everything gathering the information. So I think you could get some of the, and also an important thing is the conceptualization. Probably the concepts are very important, especially when you have a fragmented system. It's like a bridge between different systems, probably, in order to you understand in case of perception. However, when you have access to the different information at the same time, almost simultaneously, you don't need to bridge anything because everything is already bridged, right? And this, to me, might connect with the concept of duality and non-duality. So duality might appear to us as a perception in a more sequential dynamics, fragmented system, because we have these snapshots. However, if, for a more global coherent dynamics, then it will mean long coherent length. And I think this could be connected to this completeness feeling, like when you are in a fragmented system, at any given moment, the system is not complete because you are having a snapshot. So at any given moment, the system feels like it is not complete. However, when it is global, the system is already complete. So this kind of feeling of fulfillment and so on could be related to something like that. Actually, let's come back to the universe now. When we look at the sky, okay, it is amazing, you are there like, wow. But then you focus on something else, like little thing on Earth, and it's like the universe blur, right? So you don't have the perception, the clear perception on everything. You are in the small thing or in the other thing. And this is more like fragmented system perception. However, it can be that in a global perception mode, you can get both of them. You can see the sky and you can see a tree on Earth clearly at the same time. Okay, so these kind of experiences, of course, they can happen like peak experiences. I'm meditating, I'm doing something, and suddenly I have these kind of feelings. Or actually, the exception becomes the rule. It can be that the peak becomes a plateau. If we come back to our sample, it might be that you are in this chaotic state. Of course, we have to have a kind of coherence as baseline, because otherwise we could not move, we could not anything. So some coherence is there by default. But if you get through meditation and other practices, or just by nature, some partial synchrony, in this part, for instance, this is very similar to full coherent, okay? But then it destroys. So it can be that this coherence is just for a while, or the system really enter in a coherent phase. And then, so just very briefly, because I have to finish, I think this kind of fragmented versus local or global, sorry, could be also related to trauma or other problems, because actually trauma might force the system to be fragmented and get all these things. And also, I think it is very important for Kundalini. Kundalini have very extreme associations with, energetic and so on, because we are thinking on the brain, but it is the whole body, right? So I have been focusing, and of course, the Indian knowledge system have been mapping all these different states of consciousness that probably now we can start trying to understand scientifically, even though the maps are already there. So, in summary, I think from local to fragmented to a more global dynamics, we might get difference in our coherence, consciousness states, which we already know. A deep peace probably comes from the really nature of the dynamics, like in the universe, right? And when the dynamics breaks, then it changes the dynamics, maybe with an explosion, maybe with this relativistic jet or whatever. And with that, thank you so much. Namaste. Sorry.
Thank you very much. The session is open for question and answers. Anybody has a couple of questions? Yes, please.
Thank you. Thank you, Yosefa. That was really, really interesting. And I like the extension down from biology to the universe. Beautiful, based on these dynamics and spirals and so forth. My question's about gravity. Biology detects gravity, and we don't really know how or why. It's probably in the cytoskeleton and maybe in the centrioles. The reason I mentioned centrioles is that their structure is very much like the LIGO. They're cylinders in perpendicular cylinders. And Honorbound tells me that perpendicular array is conducive to detection of electromagnetic radiation directionally, so it knows which way they're coming by comparing. And I've often wondered whether they might be detecting gravity or even possibly gravity waves, although the intensity of the gravity waves would be extremely, extremely weak. But the centrioles have they're small compared to the LIGO, but they have I forget, thousands or millions of little detectors in perfect coherence that only biology can do. So my question is, what would it take to detect gravity, and could these centrioles, even though they're very small, with multiple detectors in coherent array, possibly could that amplify the signal so that they could maybe detect gravity waves? And the final point is, I saw a plot of gravity waves, and there seemed to be peaks like every 10 orders, or so many orders, that like a fractal, including one at 40 hertz where the brain oscillates. So if you comment on any of that, I'd appreciate it.
Wow, this is super interesting, actually. One will think, yeah, it is so small, the changes are so small, but if the system is working in a coherent state, then maybe that coherent state might help to detect, because one single of these parts will not. But if the system, and actually maybe we can connect that, when you do meditation and so on, you start to get feeling lighter, right? Gravity starts to feel different for your body. Of course, gravity does not change in the time you are doing meditation. So maybe you are changing your coherence at that. So I found it very, very interesting. I didn't know about it, so I don't have a deeper thought, but we can discuss it because I think it is really, really interesting. Thank you.
Yeah, hi. So yeah, brilliant talk. I think your talk also put us into timelessness, so thank you very much. Yeah, so I had a question about the last part. I've been kind of thinking about it before you reached there. So this is about the learned coherence, as you said that the coherence can be trained or learned over time. Now I was just wondering if I were to think of a practical scenario where, say, meditation, practice of meditation can put us into or can improve the states of coherence, but in practical scenarios, the practice itself is in a noisy system, in the sense that we meditate and then we go about the regular life. So I was just wondering that can the idea of learned coherence be explored where there is also noise in the system, and irrespective of that, can we have how long does it take to learn the coherence?
Actually, I think this is a key point, because I tend to, this is risky to say this in front of people that knows much more than me about meditation. So I apologize if I say stupid things, but I think it is very important. As a training, it is okay to go in a silence room and, as I was saying for the music, at the beginning, you can hear only music. You don't feel the silence in the music. So you need to first feel how it feels, the noise and the silence. But once you have a sense of it, you have to come back to music and noise and find the silence in the noise. So I think it is key. As a practice, it's okay, but life is not in a meditation room. Life is, actually, I used to go to a shopping center. It's like, you need to maintain your coherence. That's independently of you. It is not easy, but you have to practice. So we typically think, okay, I'm very good in doing this kind of meditation. If you are very good doing this kind of meditation, then do a different one. Because it's about training the system. Your system is already trained at that level. So go to the next one. Go to a shopping center with a lot of noise. Yes, yes. I think the most important is to get the coherence in a noisy scenario. Thank you.
Yeah, I have a question. You showed a slide where there were several snapshots of the brain at different frequencies, and at some, I don't remember the number, at some higher frequencies, the entire brain, almost the entire brain becomes red. So you say that the entire thing is becoming coherent at that particular frequency. That's my interpretation, right? Yeah. So the question is the implication that it has to be connected with those specific frequencies to become coherent as a functional human being or a living being? Or because I do not know, in our daily lives, our exposure to those high frequencies probably do not exist. So do I have to get exposed to those higher frequencies for the brain to get coherent? Regular frequencies are, few hertz to a few thousand hertz. So that's the question.
Yeah, this is a very good question that Anirban will need to answer. Anirban, Pushpendra, and all the team. But I think it is very interesting. I think you don't, in order to get this kind of coherence, you don't need to get exposed because externally, because you have already many rhythms that can, probably they are not in coherent way because there is inside a lot of noise or different parts that are not coherent. But it's not about getting the input from outside. But I think it is very important to research now that we have the device. Now we need to explore. These are just an example. We need to really test in a good way, but I think it's very interesting. I asked the director to, to do this kind of research because you have here the DDG. For me, this is amazing that you can actually, so you have here the facility, and I think you can do a lot of very good research on these topics that are completely new.
So what was shown was the DDG picture of the brain. So the 12, and it is all the frequencies are emanating in the brain. So and अरे sir बहुत अच्छा काम कर रहा है. It is one of the wonder of the world, and I never heard.
He is going to his master. Money has been invested. He has never told me.
अरे सर बताया नहीं है, तभी हम देखे हैं. But यथा पिंड तथा ब्रह्मांड, your profound presentation. I have never heard such things. So correlation. Thank you very much. Thank you.
Thank you.
It's a really mind-boggling. What a wonderful presentation. Thank you.
Thank you.
Thank you, Peppa. I'll like to invite our Honorable Director, sir, to kindly. Thank you.
Welcome, and we are very happy to have you here. Thank you. And
Thank
this
you.
is little Krishna. Thank you very
Thank you
much.
very much.
Namaste. What I would request all the speakers today, given that the crowd has become thin because this is the fourth day and we are already late. So if we take 30 minutes instead of 40 minutes, then we can neutralize the loss of time. Thank you.
I'd now like to invite our session chair, Professor Arnav Bhausar, to kindly invite our next speaker for the talk, Mr. Joseph Jacks. Thank you.
So Joseph has asked me to keep his, introduction very short. So I'll very, briefly introduce Joseph. He's a founder and general partner of OSS Capital, and he's also founded, in addition to that, various other enterprises like CubeNet and led more than 40 rounds of inception and seed stage investment representing over 200 millions in funding. And OSS has played a critical role in driving the creation of over 20 billion in portfolio value creation over the last 5 years. And he's also co-founder of Latent Holdings, the leading BitTensor lab stewarding most of the open source tool chain and infrastructure for BitSensor, and also maintaining Tau app and subnets 14 and 5. Yeah, so he's been around, founding various enterprises. I welcome, Joseph on the stage.
Hello, hello. Thank you, Anna. Great to be here. Thank you for the invitation to speak. And it's humbling to be among so many great, brilliant minds in the Himalayas. I'm going to go very quickly in this presentation because we have over 200 slides, but don't worry, we're going to go very quickly across all of them. This is really an intellectually curious journey focusing on the helical geometry that I've been recently enthralled and obsessed by after working with Stuart Hameroff and Anirban on microtubules and these sort of self-assembling structures. So I've selected 100 of them. I actually have an expanded version of this presentation that has like 300, but these are sort of the most interesting ones. And we go from 2,700 years ago to the present day. And you can just assume that around 50% of these have Nobel Prizes. So these are all very fundamental discoveries. So I've created an image that sort of visualizes each one, and then each slide has the same format. I won't read each slide in detail, but you can kind of see much more detail, and there's an equation for each one as well. So this is Phyllotaxis, or the Virhanka sequence. In the West, we call this the Fibonacci sequence. It was actually originally discovered here in India, I think almost 1,000 years before Leonardo da Pisa Fibonacci by Virhanka. And it's a recursive rule. Each number is the sum of the two before it. Plants in biology discovered this about 400 million years ago. And this is also known as the golden angle. So every leaf on plants lands where it blocks the last or least light, turning a sequence into a spiral. So now we go to the golden ratio. The golden ratio traces its lineage back to Pythagoras. So phi is the irrational number that it builds on, and it's a continued fraction which never takes any shortcuts. And it basically starts as a seed spiral at the golden angle, 137.5 degrees, and each new element lands in the largest gap, which gives sunflowers, pine cones, and many other amazing things in nature, this beautiful Virhanka or Fibonacci sequence. This one should be pretty obvious. This is the Archimedes screw. So Archimedes obviously was one of the many few thousand years ago well-known geometers, and this is let's see if I can shift here because I have some notes. Perfect. So this is now going to about 200 years before Christ. Hellenistic and earlier implementations existed, but this is the first technology that exploits helical geometry to perform work for screw pumps, augers, ship propellers, and conveyors. Many fundamental machines exploit this geometry. It's pretty obvious which this one is. This is the Mobius strip. So if you give a strip 1/2 twist and you glue the ends, you get one side, one edge, and no inside. And this is a topological invariant encoded by a single rotation. And actually, very interestingly, this is now the basis for quantum materials and protected surface states of topological insulators. This is a pretty fundamental one. This is the logarithmic spiral. Bernoulli loved this curve so much that he asked for it on his tombstone. And the tombstone said, "Though changed, I rise the same." So if you zoom in or out The logarithmic spiral looks identical. It's kind of like a fractal. And we see this in galaxy arms, hurricanes, nautilus shells, and many other things in nature. René Descartes also formalized this equation later, much later on in 1638. And this is also a pretty common one in nature. I'm sure many of you can guess which this one is. It's in your ear. This is the cochlea, or the spiral of Corti. So your cochlea is Bernoulli's spiral in your skull. So this is 2.5 turns mapping pitch logarithmically. Each octave is the same arc. And this is the same exact geometry that guides gene therapy to restore hearing gene by gene, which is very interesting. Kepler's laws of planetary motion. Kepler broke 2,000 years of uncertainty on orbits being ellipses, not circles. So planets actually sweep equal areas in equal times because the angular momentum is conserved. And they are nature's greatest gyroscopes. And Kepler's laws actually are still the basis for spaceship navigation today. Euler's formula. Euler's formula says multiplying e to the I theta rotates a complex number by theta. This is advancing an angle steadily while moving forward, which traces a helix. Every quantum wave function, AC circuit, and Fourier component is built on this rotating exponential. And now we actually come to the Fourier transform. So any signal, however crazy, is the sum of pure rotations. So if you wind it around a circle and you weigh the center of its mass, you've actually found the frequency. So every MRI machine utilizes this, as well as Wi-Fi, billions of times per second. Now we come to optical activity and molecular chirality. So Louis Pasteur sorted mirror image tartrate crystals hand by hand and proved that life comes in left and right-handed versions. And Jean-Baptiste Biot also observed optical activity in organic solutions. And this is actually the basis for many fundamental discoveries and drugs in chemistry. This is one of my favorite ones, turbulence and vorticity. Stokes is actually going to show up a few times in this presentation. So vorticity is the local spin of every fluid parcel, and it cascades filaments across every scale, from ocean eddies to millimeter wave rotations, converting heat. Reynolds gave us the number that predicts when calm flow tips into chaos. Gauss linking integrals. Gauss counted the number of times one loop threads into another, a pure integer unchanged by deformation. This winding number is now the Chern number of a topological insulator, and the writhe of a chromosome, and the charge of a magnetic skyrmion, which we'll learn about skyrmions a little bit later. Who's heard of skyrmions, by the way, in the audience? Wow, one hand, two hands. Of course, two. This is a really fun one. Quaternions. So Hamilton spent years failing to extend complex numbers to 3 dimensions, and he needed 4. So non-commutativity rotation algebra is why your phone knows which way it's pointing. Every 3D graphics engine, I actually have funded the largest 3D graphics engine, Godot, which is pretty fun, and spacecrafts, controllers use quaternions. So they're extremely fundamental structures for orientation. And you'll notice we're going through all the different scientific categories. So Josefa's astrological observations are pretty relevant juxtaposition to this. So spiral galaxy density wave theory also follows a spiral helical geometry, of course. Their density waves are galactic traffic jams that stars shine through, and they are briefly slowing and shining brighter. The largest coherent structures in the cosmos are logarithmic spirals, and they're self-similar curves. So now we come to Faraday rotation and cosmic magnetism. So Faraday sent light through magnetized glass and watched the polarization plane rotate, proving that magnetism and light are the same thing. This rotation accumulates across millions of light years. Radio telescopes help read it to map invisible cosmic magnetic fields. I really like Faraday because he was actually uneducated and self-taught, and he had no degrees as well, which is pretty fun. We actually mentioned this one before, but it has to get a special attention. Pasteur actually sorted mirror image crystals into two piles, each rotating polarized light in opposite directions. He proved that mirror image molecules were physically different objects, and every drug whose wrong enantiomer causes harm descends from that single experiment with tweezers and a microscope. And here's Stokes again. Stokes' theorem says rotation swirling inside any surface equals the circulation around its edge, making rotation local, measurable, and additive. Maxwell used curls to write his field equations. Every fluid simulation, flying aircraft, or modeling climate integrates this identity at petascale. So now we come to Foucault's pendulum and the gyroscope. Foucault hung a pendulum from the Pantheon dome and let Paris rotate beneath it, proving that the Earth spins, and no telescopes were needed for that experiment. Today, silicon chips the size of a grain of sand do the same thing in every one of your phones. Now, a mathematical example, this is Riemann surfaces in monodromy. Some functions change every time you circle a special point. A logarithm adds a loop, a square root flips a sign. Riemann built surfaces where this winding is actually built in, and this structure classifies topological phases and particle braiding in quantum computers. This is a very fundamental structure in quantum computers. This has been mentioned a few times in the conference so far, but this is the Poincaré sphere, polarization. Any state of light, linear, circular, or anything in between, is one point on a sphere. Wave plates simply rotate the point. Fiber optic engineers read polarization on Poincaré's sphere to double the data capacity of every undersea cable, which is pretty cool. That's how the internet works. These are vortex rings. So Helmholtz proved vortex rings are topologically stable, and Lord Kelvin dreamed about atoms being knotted vortex rings. He was wrong about the atoms, but he was right about the topology. This vision actually created the theory of knots, knot theory, and today we actually tie real knots in superfluid helium and laser-driven plasmas using this observation. This is orbital precession and Rosette orbits. So Leverrier found Mercury's orbit drifting beyond Newton's reach. Einstein's general relativity matched that drift exactly on his first calculation. And we've since watched stars trace the same precessing rosette around a black hole in our galaxy's center. Now we come to chemistry. This is the benzene ring. Aromatic rings. Kekulé proposed benzene's hexagonal ring, and London showed those electrons become persistent in current loops in a magnetic field. So this actually is the basis for nuclear magnetic resonance imaging and NMR signals of nearby atoms, and how we read molecular architectures in every drug and protein. This is extremely fundamental, found in all of biology and as well as synthetic biology. Now we come to Maxwell's equations themselves. So Maxwell's curl equations, which are incorporating the previous equations for light and magnetism, actually predict the changing fields propagating as light. In circularly polarized light, the electric field traces a corkscrew helix in space. So I actually found this very interesting. I didn't quite realize Maxwell's equations were helical, but they actually exploit helicity to come to the solution for electricity and magnetism and the resulting light. So helicity may actually reveal one-handedness in molecules in life on other planets, potentially. This is the Hopf fibration, not vibration, but vibration. So every sphere point leads to a circle in 4 dimensions, and each pair links exactly once, which is what's called the Hopf vibration. This defines the qubits block sphere. So this is also extremely fundamental in quantum computing. And this signature has been observed in magnetic Hopfions inside real materials. So this is actually also observed in biology, not just in topology. These are cholesteric liquid crystals. So Reinitzer heated a cholesterol derivative and watched it melt twice, finding a new phase of matter whose molecules march in a helical column. Cholesteric order controls every LCD pixel and many laser cavities as well, and many, many other light refraction technologies. Now we have an oceanography example. This is the Ekman spiral. Ekman noticed polar drift ice moves sideways of the wind. Coriolis rotation spirals each deeper layer rightward and slower, so velocity traces a helix with depth. This spiral carries 90 degrees off the wind, driving Earth's entire surface circulation. This is the Sagnac effect. Sagnac split a beam and sent each half around the same loop in opposite directions. A rotating platform shifted the interference fringe. Absolute rotation measured with light. Ring laser gyroscopes on this principle now guide airliners, submarines, and missiles. Many other things. This is the Bohr model and quantized orbits. So Niels Bohr produced a rule that says that only orbits where the electron's wave winds around a whole number of times of the nucleus are stable. This is the first quantum law with a winding rule. And giant Rydberg atoms in near Bohr orbits are now in qubits in neutral atom quantum computers. So there's many different ways of building quantum computers. Neutral atom quantum computers exploit this. And now a pretty famous one. Einstein's field equations are actually helical. So Einstein's field equations tell space-time how to curve around mass and energy. Black holes, GPS corrections, gravitational waves all fall from them. Every LIGO detection requires solving these equations to produce the waveform template used to identify each event. This has actually also come up in the conference a couple times. I'm sure many people know what this is. This is the Mandelbrot set by Benoit Mandelbrot, who is the founding father of fractal geometry, the field of fractal geometry. The Mandelbrot set is a boundary condition in an infinite number of spirals where the regions of near periodic windings follow a simple complex plane over the complex map over the complex plane. The universal period doubling cascade hidden here appears identically in lasers, neurons, and climate records. And topology wearing many disguises shows up here. So this is a very beautiful example of topological complexity, but it's actually relevant to many other fields, not just topology. Nether's theorem, probably the most underrated woman in science. Every conservation law is a symmetry in disguise, and Nether proved this in 1918. Rotating the universe in physics causes this conclusion, and spin being conserved. So conservation of energy and angular momentum are extremely fundamental, probably one of the deepest ideas in physics. And many people's favorite physicist, Richard Feynman. So Feynman's path integrals and Cornu spirals. Feynman's idea was to take a particle at every path once and contribute a rotating arrow. So the arrows cancel each other except in the classical paths, and the spiral summations of those arrows of Feynman's path integrals actually produced his Nobel Award-winning theory, QED, quantum electrodynamics, which is arguably one of the most precisely tested theories in science. These are Taylor-Couvette vortices. So if you spin fluid between two cylinders past a specific threshold, it spontaneously forms stacked helical vortex rings. And Taylor derived this exact critical speed in 1923. His theory matched experiment like never before in fluid mechanics. So this is a big breakthrough. Now we come to a really nice biological example. You can see the helical structures in between the membranes there. This is membrane lipid bilayer and chiral packing. Every cell is wrapped in a bilayer of chiral lipid molecules that have handedness or chirality. When handed molecules pack together, they curl into closed shells. And this intrinsic curl is exactly what engineers exploit to build mRNA vaccine nanoparticles. This is one of my favorite ones, Heisenberg matrix mechanics and non-commutation. So if you measure position sharply and momentum blurs, not from clumsy instruments, but because quantum observables are rotations that don't commute, you discover Heisenberg matrix mechanics. And this was revealed in 1925. LIGO now takes advantage of this to discover black hole collisions across billions of light years. Of course, many other things like MRI scanners and interferometers and quantum processors. This is another particle physics observation of electron spin in the SU2 double cover in the standard model. So an electron rotates 720 degrees, 2 full turns to return to itself. And this double cover geometry proposed in 1925 by Uhlenbeck and formalized by Dirac is the operating principle of every spin qubit achieving 99% fidelity in all chips. These are atomic orbitals and spherical harmonics. When Schrödinger solved the hydrogen equation in 1926, the electron wave wound exactly m times around the nucleus. M is a literal winding number. Every orbital shape, S through F, is a quantized winding pattern. All of chemistry utilizes these windings. And now, maybe the most fundamental and favorite one. I'm sure we can visualize this in many more beautiful ways, but this is the famous Schrödinger equation. A lot of people actually don't realize this and think of it just as amplitude and phase, but if you visualize the Schrödinger equation, it is a literal helix. So free quantum particles follow a corkscrew geometry. Real and imaginary parts require 90-degree spiraling. Schrödinger makes time equal rotation, and the Hamiltonian is the generator. Quantum computers basically steer these wave function probabilities to compute what is completely impossible for classical computers. These are Reidemeister moves. Reidemeister proved in 1927 that all knot diagrams reduced to 3 moves: twist, poke, and slide. This is the foundation of the knot invariant theory, which now underlies all of topological quantum computers. You might notice that the helical geometry is showing up in quantum computing many, many, many times, which is very interesting. And I think that's actually pretty appropriate given that we've observed many times in this conference that biology and life also follow this helical geometry. And this is the Dirac equation. The Dirac equation is actually fundamentally a chiral and helical equation. Dirac forced relativity and quantum mechanics together in 1928, and the math demands both antimatter and chirality, with electrons split into left and right-handed screws. Positrons that follow that prediction are now illuminating tumors in PET scans, neutrino detectors, graphene materials, and many other things. This is the protein alpha helix. So when Linus Pauling was bedridden in 1951, he folded a paper strip and found hydrogen bonds lock the backbone into a helix, 3.7 residues per turn. The alpha helix is the most abundant structure in all proteins. This is a block sphere. Qubit lives on this sphere. Poles are 0 and 1, and every superposition point between them. Every quantum gate rotates this point about some axis. The block sphere turns spin about 720 degrees and converts this strange phenomena into precise engineering language. Obviously, this is the basis for many types of quantum computers as well, trapped ion and superconducting quantum computers. Now we go to a chemistry example. This is hydrogen bond helices in water and ice by John Burnell. Even in water spirals, each molecule forms 4 hydrogen bonds into a tetrahedral cage, forcing an open helical network, which is why ice actually floats. This is very interesting. Bernal and Fowler mapped this in 1933 for ultrafast spectroscopy to watch spiral hydrogen shells rearrange in proteins. This is not a very common one, not super well known, but these are Rossby waves. Earth's rotation gives air parcels and vorticity changes with latitude. Displacing air north creates a restoring spin, a Rossby wave. Rossby derived this equation in 1939, and it actually explains perfectly every jet stream meander, polar vortex collapsing, and extreme weather events. This is a spiral cardiac and cortical waves. So when cortical excitations meet an inexcitable path, it curls around the tip and spirals into a self-sustaining motor. Halife showed fibrillation is one motor fragmenting into many. Optogenetic light pulses can now reach inside and unpin it. Arthur Winfrey is actually going to show up in a couple of slides. This is magnetic resonance imaging, very popular one. MRI is a Fourier transform of spinning nuclei, protein precesses like gyroscopes in a magnetic field. Another quantum computing example, Cooper pairs. So if you cool certain materials enough, electron pairs show up, sharing one quantum phase, and the current flows as the phase twists. This is a pretty fun one, holography by Dennis Gabor. Gabor's insight was that three-dimensional information lives not just in brightness, but in phase and in the winding of light waves. So you record interference fringes and replay the interference, rotating phase, fronts reconstruction in 3D. These are quantized vortices and superfluids. Feynman discovered this in the late 40s, early 50s. Onsager predicted this initially, and then Feynman discovered the theory. This is actually how ultra-cold atoms image vortex lattices and simulate neutron stars. This is the Aronoff bomb effect. Electron fields follow magnetism as it enters, surrounding potential alone. This is actually another very fundamental discovery for quantum computers and squid sensors, as well as Majorana fermions. This is one that you'll actually find in your fingerprints. This is the Belousov-Zhabotinsky diffusion function or spiral wave function. This is used in mixed chemical and nonlinear dynamics. And this was actually initially rejected as impossible until Zhabotinsky confirmed spontaneous rotating spirals. And these spirals are topologically identical to lethal rotors driving ventricular fibrillation. And we're getting towards the end here. These are carbon nanotubes. So if you roll graphene into a tube, the winding angle of two integers decides whether it's a metal or a semiconductor. And carbon nanotubes are essentially synthetic engineered microtubules. This is helical diffraction theory by Francis Crick. A helix leaves a telltale X in diffraction, which is actually following also a Fourier transform. The DNA double helix. This is a pretty popular example. I'll put all these slides online so people can read the descriptions later. Another biology example by Ramachandran. This is the collagen double helix. coiled coil and leucine zippers. There's Francis Crick again. This is myosin actin power stroke. Oops. This is Yang-Mills gauge theory. This is actually one of the very fundamental ones in the standard model. Every fundamental force is a rule about how quantum phase fails to return after a full loop. This is the tobacco mosaic virus helical capsid, discovered by Rosalind Franklin. And this is magnetic helicity and Beltrami fields. Magnetic helicity is the total twist of a field lines conserved in plasma and angular momentum in space. This is the MHD dynamo and the alpha effect. Rotating convection twists magnetic fields lines into helical loops. Another chemistry example, these are helicines. These are really cool, I actually learned about these. Molecular helices of fused rings. If you pack enough benzene rings into a chain, molecules cannot lie flat, and they end up colliding, which is forcing a molecular helix. This is actually one of my favorite ones. Anirban reminded me not to forget this from the amazing Pancharatnam. This is really something that should be called the Pancharatnam phase, not the Berry phase. Berry added some of the quantum aspects, but Pancharatnam discovered the fundamental equations, actually I believe at the age of 22, which is really, really incredible. We're getting towards the end here, I promise. This is the parity violation in the weak force. This is another standard model particle physics discovery. Li and Yang noticed that no one had tested mirror symmetry in weak interactions. So Wu's cobalt experiment confirmed it, and the electrons prefer one direction in opposite nuclear spin. These are Abrikosov vortex lattices and flux quantization. A type 2 semiconductor admits magnetic field only as quantized vortices. The wave function must wind by 2 pi around each core. This is magnetic reconnection. When opposing magnets meet plasma fields, the field lines snap and reconnect, releasing stored energy as fast particles. This is a very popular one in energy engineering for plasma fusion reactors. This is actually discovered by a Russian engineer, Igor Tam. So if you twist plasma field lines into a helix, it forms what's called a tokamak. That's actually how you can contain the energy that's found in stars on Earth. This is a Parker spiral and solar dynamo. I'm going to go pretty fast here to get to the end. These are neutrino helicity. So neutrinos are actually also fundamentally helical, which is really cool. These are helical magnets and spin orbitals. Hemoglobin. Hemoglobins follow a quaternion structure. This is quartic rotation. ATP synthase. In biology, life is powered by a spinning turbine, ATP synthase. This is kind of a fun one. So skyrmions are actually often characterized as hedgehog directional structures where the energy points out in opposite directions. So it winds around a physical space exactly once, and the winding numbers follow what's called a baryon number. These are magnetic spermion lattices. So chiral magnets, magnetism winding into stable whirlpools. And a very popular one here in biology, the microtubule. So microtubule follows both the Fibonacci Virahonka sequence geometry and helicity itself. This was discovered by Keith Porter in the early 60s after the discovery of the scanning tunneling microscope. This is the Lorentz attractor in deterministic chaos. If you wind a number around 3 decimal places and you watch weather simulations diverge, this is tracing a never repeating double spiral. We actually find helicity in rotating black holes in the Kerr metric. So this is also very related to LIGO detection. This is maybe one of my favorite ones. If you look up videos online of holiday junctions, they're really incredible. Holiday junctions are 2 DNA helices stranded and swapped together in 4-way junctions. and something Josefa mentioned, which is pulsars, rotating neutron stars. Jocelyn Bell Burnell spotted it precisely repeating in radio pulses. And this is a really popular one. I don't know if this is perfectly exact on the visualization, but twistor theory by Roger Penrose is deeply helical. And it's actually the basis for many subsequent theories in topological quantum computing. Froelich condensation is actually something that's been mentioned a bunch of times. So terahertz experiments on proteins and microtubules are finding the exact helical coherent rotation modes that Froelich predicted in the early 20th century, or the mid-20th century. Here's Penrose again. Penrose actually predicted the spinning black hole's momentum converts angular momentum into colossal jets for quasars. This is chiral anomaly. I'm just going to speed up towards the end here because we've got a few slides that I wanted to cover at the end. This is the circadian phase singularity by Arthur Winfrey. This is also very helical. Reverse transcriptase. Topoisomerases. These are untangling of helices in molecular biology. This is really cool. This is a particle physics discovery by Edward Witten, known as the WZW equation. This is probably one of my favorite cytoskeletal structures called the bacterioflagellar motor. It's actually a rotary motor that takes advantage of helical geometry to move cells in your body. David-Ott solitons. David-Ott solitons use what's called alpha helixes. When ATP fires in your muscles, every energy travels without disappearing. I'm going to speed up very fast now. This is, yes. This is another very fundamental one that was actually built on Roger Penrose's discoveries. This also earned a Nobel Prize. Roger Penrose should actually, in fact, have 2 Nobel Prizes for this. If you factor twistor theory and a few other things, he may be the only person in human history that potentially could be worthy of 3. Dan Sketchman was ridiculed by Linus Pauling for most of Linus Pauling's career, saying that quasicrystals were impossible. And Dan Sketchman actually used them by building on Roger Penrose's aperiodic geometry, icosahedral order, which is hexagonal. So I'm just going to speed up a lot very fast and just show you the slides and then go to the very end. There's some really beautiful ones in here. All of the cryptography on the internet uses helical geometry, elliptic curve cryptography. CRISPR-Cas9 also uses the helical geometry of the double helix in RNA for displacing strands. Quantum anomalous Hall effects, also very fundamental in all of quantum computing. Chern-Simons gauge theory, there's another one. Orbital angular momentum is also fundamentally helical. Beta proteins and amyloid fibril architectures. Shor's algorithm, so it's a quantum version of the Fourier transform. Shor proved that quantum computers could factor huge numbers doing this. And this is a favorite of mine. I don't know if this is a great visual, but it's a nod to Roger Penrose and Stuart Hameroff for orchestrated objective reduction, which is the only experimentally verifiable theory of consciousness. Another thing I think that people really forget and don't realize with Stu is that he was a practicing anesthesiologist for, I think, 50 years and successfully anesthetized, which is the process of creating unconsciousness and then applying enough of the effect so that people actually wake up successfully so he doesn't kill people. And I actually asked Stu a question, did you ever accidentally kill anyone? I mean, probably witnessed people who passed away for whatever reason. And he said no, so that's pretty incredible for a very successful career of being an anesthesiologist. So I think that gives him a lot of credibility that, frankly, none of the other consciousness theories have in actually mechanistically interacting with consciousness. So we're almost done here. This is another really popular one. If you go into quantum computing, this is very, very popular and fundamental by Alexei Kitaev, braiding anyons. And some more biology, chemistry ones. Chirality-induced spin selectivity. This is also very popular if you're looking into proteins and engineering things. Ribosomes are RNA helices. Well, actually, I should mention that one. That's by Venki Ramakrishnan. This is the viral packing motor. Hopfiance, knotted field textures by Heinz Hopf, obviously very helical. Topological insulators, Charles Kane. And this is not a very good visual, but this is Time Crystals by Frank Wilczek. Frank cited Arthur Winfrey in his discovery paper in 2012, but if you read The Geometry of Biological Time, which I recommend everyone reads, it actually is the first appearance of the word time, or the phrase time crystals in the context of biological systems. So I would actually give credit for the discovery and sort of characterization of time crystals to Arthur Winfrey. But Frank Wilczek is a Nobel laureate for one of the strong nuclear forces, and he's been more popularized for this concept recently. And one thing that I think is worth mentioning on building on Roger Penrose's twister theory, if you dig into some of the latest research around mathematical physics and topological theory, this thing called the amplitahedron actually builds explicitly on Roger Penrose's twister theory, and it's actually one of the more exciting topological quantum theory field theories out there. And the last one that I would say, and I think Anirban is not here, he's maybe working on his slides, but this is a, he is there. This is a upgraded rendition of the title of his book, Nanobrain, which is, I would argue, one of the most fundamental sort of flavors, or maybe the most fundamental flavor of a time crystal, called polyatomic time crystal. And this is where time crystals actually follow a fractal self-similar geometry. And these are obviously the basis for how you can construct and fully understand the human brain and maybe all living systems potentially. And so I want to wrap up with a few comments. If you really look at the helical geometry in nature and math and chemistry and astrophysics and chemistry and all these different fields, it's pretty clear that nature and reality computes things in helices, and DNA replicates, microtubules carry cargo, ATP synthase spins, neurons phase lock, polarization carries qubits, and we've really just barely started. If you look at computing and the technology industry, our silicon chips are flat, they're two-dimensional, they're not three-dimensional. They ignore chirality. They are geometrically inept, if you want to think of it that way. And the degrees of freedom that biology has been exploring for billions of years just are not there. So what I'd like to propose is really the next frontier of computing, which will likely be quantum, must necessarily take advantage of this. And I'll leave you with this last slide. 2 books I would recommend everyone reading. Nanobrain by Anirban and Ultimate Computing by Stu. Stu wrote this book a few years before I was born, so I don't want to age Stu. I'm 37. He wrote this book, I believe, in 85 or 86, and it is probably one of the most profound books ever written in the history of science. I had the AI fact check me on this, but Stu cited no fewer than 15 future Nobel laureates in this book. And they weren't Nobel laureates like of the next year or of the next 2 years. It was like the 80s, the 90s, the 2000s, the early 2000s, the mid 2000s. And it's extremely profound what Stu observed in this book when he was working at a cancer lab looking at cellular division and mitosis and concluding that microtubules were really a computing mechanism and a computing device. And obviously he's inspired many people like Anirban and others and many researchers around the world to sort of take the cytoskeleton seriously as a very fundamental structure. And Anirban's work is obviously one of the really big examples of building on that. So with that, I'd like to leave you with these 2 books. I hope you go out and buy them and read them. And it's been a pleasure giving this presentation. Thank you. Maybe one question.
Yeah, thank you, Joseph, for taking us on a tour of order in the universe. So we would of course like to add some to this list, starting from the BCs like Aryabhattas, Baramiras, and we'll send you that list, and even the modern ones like S.A. Bose. So I think since we're already kind of running late, I'll have just one question.
Uh, So bring hydrogen bonds. Body is 70% of water, so H2O. So it's bring that hydrogen bond at one place, and we get analysis or we get imaging. As you've shown that in MRI. What at this moment India is lacking for the development in MRI. Every district have one or two equipments. What we can do to integrate to the human body?
Well, I'm not an expert on any of these things. I'll say I'm just a curious person, and most definitely the top most unintelligent and uneducated person in this room, probably. But I'll say if you look at this presentation and you sort of take away some observations, you'll notice that this helical geometry is extremely fundamental. And again, I think 1 out of 4 Nobel Prizes have sort of exploited and built on this. And so I think better machines and better instruments in the future will absolutely take advantage of this geometry. And like I mentioned in these 2 books that I'm recommending everybody read, I think if you read them, you'll see that we need to engineer our computers differently. And of course, most technologies, including instrumentation in hospitals, are built on computers. And so I think if we exploit the same geometry that nature has created and discovered to produce us, I think that'll allow us to create really the ultimate computers. So an homage to Stu there. So anyways, thank you for your time. Appreciate it. No more questions. The slides will be on the internet. Thank you. Thank you, sir. Thank you so much.
I now request our Honorable Director, sir, to session the chair
Thank you so much. Can I give
Of-
you this as well? Thank you so
Professor Nachiket Tiwari ji. Thank you.
I would like to have a copy of your.
Oh, sure.
Yeah.
Yeah, of course.
Can you send me the WhatsApp?
Sure.
But it's so nice.
Thank you.
I'm happy to introduce my own colleague from IIT Kanpur, Professor Nachiketa Tiwari, who is a professor in the Department of Mechanical Engineering at Indian Institute of Technology, Kanpur. He obtained his PhD in Engineering Mechanics from Virginia Tech, USA, and has extensive academic and industrial experience in the field of acoustics, vibration, composite structures, product design, finite element analysis. His research interests include acoustics, noise control, solid mechanics, automotive systems, MEMS, structural dynamics. Professor Tiwari has contributed significantly to interdisciplinary research and engineering education through several publications, sponsored projects, and NPTEL videos. He is also known for establishing advanced acoustic research facility at IIT Kanpur and for his work in vibration control and composite material. He is going to speak today on Hindu hermeneutics, its importance and relevance in context of our understanding Bharat. He has been an active person in developing the proper framework by which Hindu ideals needs to be presented. Welcome, Professor Nachiketa Tiwari.
Thank you. So I have, how do I, this one? Yeah. So I'll try to finish my presentation and talk within the time which has been allocated. And I just wanted to mention one important thing, that as I was defining the title of this talk, I paid a lot of attention whether I should be using the word Hindu or Indian or Indic, and whether I should be using the word Bharat or India and some things. And the reason I chose these terms, Hindu and Bharat, it's not because it alludes to some religion or something, because these two words relate to a particular ontological framework and also an epistemological framework. And when you use the word India, it does not evoke that particular ontological and epistemological framework. So that is the context in which I use the word Hindu, hermeneutics. Why is it important, and why it is extremely important if we try to understand Bharat. And as we are here in context of this mind, body, consciousness related, this is the overarching theme. Again, it will relate to that particular theme, because if you have to understand the way Hindus have understood it, you need a particular epistemological framework, which is different than the current epistemological framework which is being used across the world, which is essentially a Western or a European framework. And there are issues and problems associated with this. So I'll cite some of those issues. So for those who do not know the dictionary meaning of the word hermeneutics, it took me some time to figure that out because it's not my language. It's the science or method of how you interpret a text. And the word text also comes from humanities. It's a much wider term. So what is a text? And if you go and talk to humanities professors, it's not just the written word. Anything that carries meaning. So we saw all those images, they are texts. Words, sentences, passages, pictures, symbols, signs, music, sound, video, graphs. Whatever you see and experience, if you try to make meaning out of it, it is text. So the importance of hermeneutics, it applies to everything whenever we try to make sense out of our experiences. So it's extremely large in scope, and that is the context in which we have to understand why it is important to strengthen and develop this area, Hindu hermeneutics. Because the person who decides the meaning, who shares and explains the meaning, that person shapes the narrative. Now, this is a conference primarily of scientists, but I think it's important to understand how has Bharat been interpreted over last 200 years. This is not an occasion to complain or whine or come out with grudges, but understanding that there has been a Western framework, epistemological framework, and using that, how has Bharat been interpreted? And I'll show you some 3 or 4 examples of it. Actually, I have 5 examples. So this is a passage. It was written in this paper, Teaching History in Schools, the Politics of Textbooks in India, History Workshop Journal, Niladri Bhattacharya, Oxford University Press, 2009. Now, for those who do not know who Niladri Bhattacharya is, this gentleman was leading a committee who wrote all the textbooks, history textbooks in our country. And this was during the period of 2009 to 2014, during that time period. So this is an important person who actually wrote those textbooks. And look at how he expresses when they were writing those textbooks. This is what he says. So this is in 2009. The earlier textbooks were narratives of the nation. Could we get away from this narrative? What could be the strategies to deploy? We problematized the idea of the nation in a variety of ways. We reframed the history. See, so you are changing the frame as our pasts. The point is he's using a plural word, pasts. So there's no single past. India does not have a single past. It has plural pasts. This was to underline that there's no single narrative. There's no one national past. It is to recognize that different communities have specific histories that cannot be encapsulated within the story of the nation. So essentially, the overarching message is that Bharat is not a organic unity. That is the point. The second one I'll refer to is a book. This gentleman, Paul Courtwright, he's no more. He wrote a book which was very popular, Ganesh, the Lord of Obstacles. And in this book, he interprets the traditional story where Ganesh is, his head is severed by Shiva, for reasons all of us know, and then it gets replaced by an elephant head. So it is interpreted is that there is a son and there's a father, and they are competing for the interest and the attraction of the woman, which is Parvati. So he is using Freudian framework to interpret a Puranic story, and there are scores of such instances when you go and see how Indian stories or Hindu stories are interpreted. So this is another example. The third one is I'm quoting Niladri Bhattacharya, and how this religious bigotry gets rationalized and it gets reframed. So he says secular histories return to the past to counter these claims, to build an alternate social memory. So you want to change the memory of a society. Then he gives an example. Memories of Somnath, we are told, nurtured a profound feeling of anger, shame, and hurt. Habib, that is Irfan Habib, he says, was the first to confront this social memory of these invasions. And how does he do it? He first showed that he was driven by greed and lust and not bigotry. So you are rechanging just to suit a particular narrative. Second, he suggested that such memories were produced by a colonial education system. You're suggesting, you're not proving it. And third, he says that there's a long history of syncretism, tolerance, and inter-community exchanges. The fourth example is another book, and then I have one more, and then we'll move to the other theme. This is a book by Jeffrey Kripal. He's a professor of religion in Rice University. He's a very learned person. He has spent a lot of time in our country. And then there he explores the relationship between Vivekananda and Ramakrishna. And Ramakrishna, the guru, has a lot of affection for Vivekananda, and he interprets it, again, in a sexual way, and he says this is the example of a homoerotic relationship which also has something to do with mysticism. So this is a passage through extended textual symbolic analysis. Again, it's symbolic, there's no substance there, of Ramakrishna's censored secret talk. Again, that talk is not documented, but some invented secret talk. Kripal demonstrates that the saint's famous ecstatic and visionary experiences were driven by mystico-erotic energies that he neither fully accepted, and so on and so forth. And the last one, and then we'll move to the second segment of this presentation, is there is a formal, conscious, acknowledged, and considered valid method where you actually formally replace facts with narratives, and that doesn't work in the scientific world in which we are sitting here. And this is again an acknowledgement. These are all self-acknowledgements, so I'm not imputing, or I'm not saying that, oh, you are like this. They are themselves saying. So this is again Niladri Bhattacharya. He's talking about Romila Thapar. He says Thapar's account shows how secular histories now operate with new narrative strategies. So remember, fact is being replaced by narrative. And then he actually says that earlier historians were considered with facts, from an earlier concern with factity, whether or not the specific event happened, whether its memory was true or false. Historians have now turned to exploring the politics of memory, attempting to understand what's remembered and what's forgotten, showing how collective memories of trauma and humiliation are often shaped by what we read. So essentially, the gentleman is arguing that you have facts, you can ignore those facts, and you replace them with narratives. And this is actually a direct consequence of this postmodernist framework of analyzing stuff. The point is that I can say that, oh, these guys are bad people and they interpret it knowingly in a wrong way. But that may not necessarily be true. The way I look at it is that all such interpretations need not be malintentioned. They may be genuine, but they may not be correct. There's a difference between those two. You may do it because you are thinking you are doing the right thing, but you may be doing the wrong thing. A person interprets in context of his or her experiences, and a person's culture is the crucible of his experiences. So the dominant way to interpret any text, whether when we talk about printed matter, pictures, graphs, videos, whatever shapes, forms, it is anchored based on certain way of interpreting stuff, and the present dominant methods of interpreting stuff has been generated in European and American universities, and they are anchored in Western historical experience. And if you do not understand that Western historical experience, you do not know where those interpretations are coming from. So the civilizational background of the interpreter, it strongly influences the meaning of the text. Unless you are not tuned to that civilizational experience, you do not really know whether that particular interpretation is contextual or it is pretty generic. So if you go back and try to understand the entire history of Europe, its origins, and you try to bring out 5 or 6 more most important themes which run through the entire historical experience of Europe, what are those features? What is the swabhav or the inherent nature of Western civilization? Because only with that experience they come up with these interpretational methods. So the first feature is that it's a very unique civilization. It has 2 roots. And the first root is Greece. A lot of inspiration comes from the Greek history, and then later Christianity comes to Europe, so that is the second root. So there are 2 strands, and they actually mutually complement and reinforce each other. And the second feature is that both these roots, they talk about 2 worlds. So earlier we had the professor from Spain, the lady who was talking about, at the universe level and on the biological level, they are talking about some underlying unity. But if you look at these 2 roots, the Greek root as well as the Christian root, both these traditions, they talk about very fundamental duality, that there's one perfect world out there and there's an imperfect world which is here where we are living. And we are living in an imperfect or a sinful world. So that's idea comes from the Christian theology. From the Greek root, you have this idea of Plato, who talks about the world of forms. And what does he mean? So you look at this is the letter A, this is another letter A, this is another letter A, this is another letter A. All these are different forms, different colors, different shapes, but we still identify these letters as A. Why? So Plato actually asked the same question, that there is so much imperfection, but I identify them with some specific names. I call the circle as a circle, but I never see a perfect circle. So he postulated that this is an imperfect world, and you see all these imperfect expressions of A, but there's another world, which is the perfect world, the world of forms, the world of ideals, and all these are basically reflections of that ideal A in that perfect world. So in the Christian side, you have an imperfect, sinful world, which is earth, and then there is heaven. And then on the Greek side, again, you have an imperfect and a perfect world. So again, it's there. The third feature is that both these roots, they reinforce the idea of duality. Duality. That, so earlier we were talking, two presentations back, there was a discussion on some underlying unity or, coherence. But here, this is a very fundamental idea which runs down through the entire civilizational experience, that there's duality. And when there is duality, you have this small passage in Vredaranyaka Upanishad, when there is duality, then there will be fear. Dutiyadve bhayam bhavati. If it's one, then there is no need to fear. If there are two, then A will fear B and B will fear A. So you have two. And the moment you say that this entire universe is having two parts, there are two entities, there are two sides, and two, you have this psychology of fear, psychology of suspicion, and that has its own consequences. The fourth feature, and this is also extremely important, and again it relates to the presentation we saw earlier also, that the Western experience or the tradition plays an extremely important focus on logic. And it says that without logic, logic is the ultimate truth. Without logic, nothing else is valid. The Hindu experience says, yeah, logic is important, but unless it gets substantiated by direct experience, anubhav, that logic can lead you to strange answers. So you can come up with any sort of logical scheme and you can prove anything, but unless you correlate it with strong experience, strong data or anubhav, that doesn't make sense. Actually, that's the fundamental divide between philosophy and darshan. So the Western argument is logic supersedes experience, because again, in the world of knowledge, experiences can be imperfect, and so they are relegated to a secondary status. Logic is superior. Again, duality. And this idea, it gives you to the birth of dialectics, where there are two contending sides, duality, there's duel, there's fight, and then one has to win over the other. But the Hindu thought is that without anubhav or experience, direct experience, logic can be used to prove anything. The next feature is, so once you have duality, dialectics, two conflicts, you have power tussles. And you see it in the history. You have Greek mythology, you have the first generation of gods, then there's a second generation, and there's a power tussle between the two generations of gods, right? Then there's a third generation of gods, and then the third generation has a power tussle with the second generation of God. So that it starts right from the Genesis. Then you have power tussle between God and Satan. Then you have power tussles between God and demons. And who are demons? So when Christianity comes to Greece, they were worshipping a lot of gods and goddesses, and all of a sudden they were relabeled as demons. So you have God, capital G-O-D, and then everything else was demon. I mean, that's how this word demonization comes into operation. So this conflict is there, and it's a recurring theme in European civilization. And because of this, you have a relationship that there's power. Power generates, authority. It also gives you, the latitude to issue commandments. And if you agree with the commandment, you are ideologically pure. And if you do not agree with the commandment, then there's a problem. So power leads to authority, leads to commandments, and leads to ideology. Sixth, because there is duality, there's identity. And if there is identity, and this relates to our Mbcc conference also, who am I? And if there are contending identities, there will be identity-driven conflicts. So what kind of conflicts? The entire literature, when you see, you go to any university, you will see, especially in the humanities side, in science we don't do this. You will see gender analysis on planes of gender, gender-driven conflicts, gender-based identity and gender-based conflicts. Language-based conflicts, language-based identity. You go and look at the map of Europe. If you take out 7 or 8 countries from there, every single country has a national language, not 2 national languages. Every single country has a national languages. So you have Spain, Spanish, France, French, England, English, Germany, German, Holland, Dutch, and so on and so forth. One country, one language. Race, again an identity. Now it's gotten obsolete because we couldn't find any genetic basis for that, but again, identity, and it has driven a lot of conflicts. Class and caste. Caste got invented here because of Western scholarship. And class, again, this is identity between bourgeois and proletariat, or in modern terms, between the oppressor and the oppressed. And then everyone, if I ask anyone in this country, in this room, are you an oppressor or an oppressed? The natural reaction will be, oh, I belong to the oppressed people, and others are oppressing me. So again, there's a basis for conflict. Oops, sorry. Culture, conflicts driven by culture. Nationality. So, and all these bases, all these identity-rooted distinctions, you can trace them in both the roots of the civilization. The 7th feature is sexuality as a recurring theme. And this is important. So you see, when you have these Greek gods, there's contestation for attraction of a woman, and sometimes there's incest, there is repression, and it leads to consequential strifes. So again, within the Greek mythology itself, you see a lot of references to direct references, so you are not interpreting it. And then that series of these types of activities continues, and that's how this Freudian psychology takes birth. So this is the landscape. It's not my argument whether this is good or bad, but this is the landscape, this is the historical experience, and this gives rise to the intellect of Europe to interpret the world in certain ways. So what are the certain ways through which a modern humanist or a person who's in the humanities department, he or she interprets the world? There was a colonial method. It's probably now obsolete. There are still some people who are sticking to the colonial method. And the primary thrust was that there is a colonizer, there is a colonized. The colonizer is an enlightened person. The colonized needs to be redeemed. He needs to be civilized. So whatever we are doing good to you. So that's how it was interpreted. Civilizing mission. Then we have the birth of Marxism, again anchored in this duality between proletariat and bourgeois. Again, there's a strife between bourgeois and proletariat. The proletariat are the good guys, bourgeois have to be eliminated. And in that context, you analyze all the societies. So when you analyze Indian society, you say, oh, this represents the rich guys, the bourgeois, and this represents the proletariat. So this is another way to analyze it. An improvement or an advancement of that was the critical theory. So critical theory, the theorists, they were very serious and very, very knowledgeable people in Germany. They developed this theory in Frankfurt, and then they later migrated to United States. They established themselves in Columbia, UCB, and Chicago. And they said that Marx framework is fine, but we'll generalize it. It's not just bourgeois and proletariat, it's oppressor and oppressed. So you can have all sorts of oppressors, and you can have all sorts of oppressed people. And whenever I analyze a text, say I'm analyzing Ramayana, So I will say, okay, Ram and Ravan, who does Ravan represent, who does Ram represent, and based on what you want to interpret, you can say that Ravan is an oppressed, Ram is an oppressor, and you frame it in that way and you come up with an interpretation. And then there's this feminist method. Again, it's born in historical experience that there was significant discrimination and injustices against women in the European history, and that led to a rebellion. And again, the focus is on gender-based differences, gender-based exploitation, and expressing and interpreting in that context. Then you have the psychoanalytical method of Freud, which I already talked about, where you interpret relationships between men and women, fathers and sons, and so on and so forth, in terms of Oedipus complex, repression, penis envy, and so on and so forth. That's the framework. There's no actually hard data whether those theories are actually true or not, but you interpret it. Actually, Karl Popper, he's talked about this, and he said that Freudian framework is unfalsifiable, but in humanities, people stick to it and they keep on interpreting it in that way. And then you have this postmodernist method, which talks about the importance of narratives, the argument that there is no truth. There is no truth. If there are 100 persons, they have 100 versions of truth. Each version is equally valid. The truth need not be supplemented by hard objective data, which is anathema to folks like us here. And that gives you a license to come up with any story, you call it narrative, based on quote unquote lived experience, and you can interpret things in any way you want. And then there's the post-colonialist method, and so on and so forth. So, the importance of these theories is we should not take them very lightly, because it influences all departments in all universities across the world. I'm not just talking about our country. And these are the only ways texts are being interpreted. I'll just give you an example. So this is the fount of our narratives on gender, narratives on caste. Everywhere you are exploring duality, conflict. And then the way you solve this conflict is by canceling the other side. There is no other approach. Identity, sexuality, power, race, language, region, religion, and so on and so forth. It drives the direction of scholarships in all humanities disciplines, whether you are expert in area of law, language, political science, sociology, international relations, cultural studies, literature, philosophy, design, arts, aesthetics, psychology, music, economics, whatever. This is the framework through which knowledge and text is being analyzed. And the consequences that every day you have more and more of same type of stuff which promotes division, inharmony or disharmony, and strife, with the hope that this strife will get resolved by elimination of this other guy, and eventually an utopia will get established. But that never happens in reality. And they are often treated as universal theories, not as European or Western theories. And some of them have explicit ideological goals. For instance, a lot of these critical theorists, their stated objective is to establish Marxist utopia in the society. So they interpret anything with that stated objective. And that is the context in which we need a Hindu hermeneutics. We have to develop this idea, and a lot of serious thinking has to accompany it. I'll give you an example. Now, I don't know if folks at the back, they can read it. The pervasiveness of this way of interpreting things is in all departments. Behraji is from Odisha. If you go and look at UGC net of syllabus of Odia, you will find similar stuff. So this is an extract from the UGC NET syllabus of Hindi. So if you want to get into PhD program in Hindi, you have to clear UGC NET. And what are you expected to know? Because unless you know, you will not be able to interpret Hindi text correctly. You have to see the last line. You have to know Marxism, Freudian psychoanalysis, existentialism, postmodernism, identity-based narratives. You have to know Ambedkar Darshan, Gandhivadi Darshan, Lohia Darshan, Mahid. But last line is important. When you are trying to understand language and literature, you have to understand principles of Aristotle, Wordsworth, Coleridge, Eliot, Richards. So these things have gotten into every area of education. I looked at syllabi of Odia, Marathi, Hindi, Bangla, Tamil. There's no Hindu hermeneutics in it, even though all our texts are inspired on some other sets of principles. The other important thing is, it's not that only we are the people who are getting misinterpreted. If you look at Japan, Africa, China, their societies are also getting analyzed and interpreted in the same framework. This is also there. Third, the effects of such interpretation, which is based on duality and conflict, is being witnessed by the American society also, because now you see a lot of friction and disharmony arising in that society also. So there are alternative frameworks for having a different way of interpreting text has to be developed. Maybe there are some other approaches, but at least I am aware that the Hindu civilization does provide a framework for interpreting texts differently. So this is probably the last slide. How does a Hindu view things and reality? The Hindu says that logic is extremely important, but unless that logic is substantiated by direct experience, it is of suspect variety. So Anubhav is the source of Prama. Prama means valid knowledge. Anubhav is direct experience. Direct experience is the source of all valid knowledge. This is the foundational idea of Hindu darshanas. Whether it's a Buddhist darshan, Advaita, doesn't matter. Anubhav is the source of all pramana. Second, the Hindu sees this universe, not just earth, as one organic entity, not two, not multiple, disconnected, inchoate, contending, conflicting entity. It sees this entire universe as one organic entity. There's some unity underlying this entire universe, and whatever diversity we see is just a manifestation of that underlying unity. In Rigveda it says Rupam, Rupam, Pratirupam, Babhu, and so on and so forth. That all this diversity you have is nothing but manifestation of that single unity. It's not uniformity, it's unity. Third is the operating principle, and in plain words, if you do something, it will have consequences. If you do something, you cannot get away with the consequences. Maybe it will not happen immediately, but the consequences of an action will be there either today or 10 years from today. So how do you choose what to do and what not to do? And that is the regulatory principle, that there are some things which you would like to do, which are desirable, which are preferable, which are aligned to the overall health of this cosmic unity, that is dharma. If you violate that, that is adharma. And what is the purpose of individual existence, human existence? So the European thought says you have to focus on your identity. The Hindu mind says you have to transcend identity so that you can discover that unity. You have to transcend that identity. And commandments and beliefs are not important when I am talking about knowledge. Praman, that is evidence, is. So whenever I am having a discourse, I cannot validate my discourse because of some commandment, using some commandment. Rather, I have to use praman, that is evidence, to substantiate whatever I am claiming. And this thing holds true whether I am in the area of science or humanities or spirituality. So this provides the framework. A lot of work needs to be done. We have started doing some workshops, very intensive workshops in this area, but I just wanted to bring it to your attention. This is a very important area to be developed, Hindu hermeneutics, and it will answer a lot of questions in context of the transactions which are happening even in this August gathering. So I do not know whether I was on time, but if you have any questions, kindly let me know.
Thank you, sir, for a very different perspective. But the question is, when a researcher tries to analyze the text, so how do he apply the Hindu hermeneutics to study something? Can you please elaborate a little?
Yeah. So the aim, the purpose is now we have to start creating a lot of textbooks, but 3 or 4 broad principles, what I have understood till so far, it's a work in progress, and I'm not the final answer. But there is a very strong tradition of Nyaya. And the entire Nyaya tradition is centered around providing praman or evidence. There are 6 categories of pramanas, right? 6 types of evidences. So the Hindu idea says that whenever you make a claim, substantiate it with evidence. That is the first foundational principle. Second, in the area of Mimamsa, there are formal ways of interpreting a text. So I can still provide all the pramanas, but I can still have multiple interpretations. And that's fine. But there are formal frameworks of how you interpret a pramana, a text. And there is again a method, adhikaran method, and shuttling with 6 parameters. So you have to see what is the time, what is the place, what is the context, what happened earlier, what happened later, what is the intentionality of the author, and so on and so forth. So there are formal ways. You can still come up with multiple explanations, multiple interpretations, but those will not be imagined. Those will be still based on your impetus and urge to arrive at the truth. So some broad principles. And the third one is understand the meanings of the words correctly, and understand those meanings which were used by the author with the intention which he or she used. So that understanding comes if you understand this logic of Nirukta and Vyakaran. Some broad principles.
Thank you very much, sir. See, Karma Yoga, the karma is the operating principle. Our director had wrote the book, the latest. Now, when I look for, as you mentioned, every action is a equal and opposite reaction. That in the way Newton's law, and that changed the most of the centuries, kings, queens, and a lot of things have changed. Now, when I look for the pramana, Menkav, the Hitler book, My Sangharsh, been sold in India over 1 million copies. Now, Machiavelli and Freud, we are only teaching at the management level. They are not at local level. They are not at the even university. Very few people know that. So, in the future, can we see, on the basis of karma, because there is the oppressed and the oppressor, which are most dominant in the society today, can we see a Hitler coming into...
So, I mean, this is talking about future and making predictions, so I will not go there. I'm just talking on this theme, hermeneutics, so I think we should just focus on the theme of this presentation, that's all.
Okay, so let us thank Professor Nachiketa Tiwari for his
You have a talk, a question? Yes, yeah.
Thank you, sir, for this very lucid presentation and bringing in the contrast, facts, narratives. I have a very fundamental question that when the ontology and the epistemology are so different, but there is still a struggle to fit one onto the other. So what are the plausible steps that we could take to bring this kind of acceptance?
As I said, textbooks, you have about ontology, about epistemology, about hermeneutics. A PPT is not an alternative. It's a 40-minute presentation. So we have to work hard and be reasonable, use praman, use those traditions, and come up with something concrete which I can have it in hand and share it with others.
What about those who are in colleges, universities, they have to publish scopus, and we need to somehow fit there, and there are people who take decisions and who are not yet
Again, that
abreast
is...
of this. What do we do about that?
No. So that is again prescriptive thing. I will not go there. All what I'm saying is that there is a requirement, and if we think it is important, we have to work hard and fulfill that requirement. How do you do it? वहाँ क्या modalities हैं? कौन करेगा? कौन नहीं करेगा?
Those
not
are
about
detailed.
it. That's
Okay, okay. Thank you. Wait. At present.
Thank you. Thank you.
So, this is time for tea, right? It's time for tea. We still have 4 talks. I would like all of you to come as quickly as possible so that we can start the next session. Thank you very much.
ठीक है सर।